Part 1, Introduction to Solutions. What is a solution? A solution is a homogeneous mixture of two or more substances. The substances can be solid, liquid, or gas. Example, sugar dissolved in water, solid plus liquid, air, gas plus gas, alcohol mixed with water, liquid plus liquid. Components of a solution: 1. Solute, the substance that is dissolved, present in smaller amount. Example, sugar in sugar solution. 2. Solvent, the substance that dissolves the solute, present in larger amount. Example, water in sugar solution. Binary solution, a solution having only two components, one solute and one solvent. Example, salt, water. Types of solutions based on physical states. Solute, solvent, example. Solid, solid alloys, e.g. brass. Solid, liquid, sugar in water. Liquid, liquid, alcohol in water. Gas, liquid, oxygen in water. Gas, air. Gas, air. Solution kamatlab hoda hai ek aisa mixture jo ekdam uniform homogeneous hoda hai. Do components hote hain solute jo gulta hai or solvent hai. Agar sirf two components hain to usko binary solution bolte hain. Solution main solute और solvent दोनों की identity खत्म नहीं होती, लेकिन वो इतने अच्छे से mix हो जाते हैं कि अलग नहीं की जा सकते simple तरीके से. Examples to remember: solution type example, solid in solid, brass, copper, zinc, solid in liquid, salt in water, liquid in liquid, vinegar, acetic acid, water, gas in liquid, soda, 2 in water, gas in gas, air, O2 N2. Ye part 1 complete hua agar 2. Solubility of solid in liquid. What is solubility? Solubility is the maximum amount of solute that can dissolve in a given amount of solvent at a particular temperature to form a saturated solution. Roman Urdu, solubility ka matlab hota hai kitni maximum quantity kisi solute ki dissolve ho sakti hai, ek solvent mein ek fixed temperature par, bina or dissolve hu. Tasher factors affecting solubility of solid in liquid. 1. Nature of solute and solvent, like dissolves like. Polar solutes dissolve in polar solvents. Nonpolar solutes dissolve in nonpolar solvents. Example, sugar, polar, dissolves in water, polar. 2. Temperature. Generally, solubility increases with temperature for solids. Example, sugar dissolves faster in hot water than cold water. 3. Pressure. For solids and liquids, pressure has negligible effect on solubility. Graphical understanding. Diagram banasakten exam main. X-axis temperature, y-axis solubility, curve, upward slope, mostly for solids. Roman Urdu summary. Solute or solvent ki nature same honi chahiye, like dissolves like. Temperature badni si solids ki solubility zyada hoti hai. Pressure ka solids ke sath zyada effect nahi hota. Simple example. Salt in water, soluble. Oil in water, not soluble, because polar or non-polar mix nahi hote. Ye part 2 ya next likhain, to whom part 3, solubility of gas in liquid. What is solubility of gas in liquid? It is the amount of gas that dissolves in a given amount of liquid solvent at a specific temperature and pressure. Roman Urdu, gas ka solvent liquid, main dissolve hunk amount fixed temperature or pressure par, isko gas ki solubility bolte hain. Factors affecting solubility of gas in liquid. 1. Pressure. As pressure increases, solubility of gas increases. Explained by Henry's law. 2. Temperature. As temperature increases, solubility of gas decreases. Gases escape faster from warm liquids. Henry's law statement: at a constant temperature, the solubility of a gas in a liquid is directly proportional to the pressure of the gas above the liquid. Formula: P equals KH times C, where P equals partial pressure of gas, KH equals Henry's constant, C equals concentration of gas in liquid. Roman Urdu, jab pressure badhate hain to gas zyada dissolve hoti hai. Henry's law ka simple concept hai. Temperature badhain per gas ki solubility kam hoti hai. Applications of Henry's law. Soft drinks. High pressure CO2 is dissolved in drinks. JC bottle holti hai, pressure kam hota hai. CO2 bubbles nikalte hain. Scuba diving. High pressure main divers ki blood main gases dissolve hotihen isi wajah se deep sickness ya bends hotihen agar suddenly upar. High altitude sickness. High altitude par pressure kam hota hai. Isi wajah se oxygen ki solubility blood main kam ho jati hai. Breathing issues. Important points. Factor, effect on gas solubility. Increase pressure. Increase temperature, decrease solubility. Simple example, soda bab al jab dandi hai tab zyada fizz hoti hai. Garam karne par se gas jaldi escape karta hai. Ye part 3 complete hua. Standing, Shah Henry's law, deep explanation. Nash 1. Solubility of gas and pressure. Statement. Solubility of gas is directly proportional to pressure of gas above the liquid. Formula, mass terms M equal Kp, where M equals mass of gas dissolved per unit volume of liquid, K equals Henry's law constant, P equals pressure of gas, Roman Urdu, gas ka mass jo dissolve hoda hai, wo pressure ki directly proportional hai. Pressure badhao, dissolve hone wali gas ka mass bhi badhega. Gap 2, solubility in terms of mole fraction. Jab solubility ko mole fraction main diya jata hai, formula modify hoda hai, P equals KH tie, where P equals partial pressure of gas, KH equals Henry's constant, chi equals mole fraction of gas in liquid. Roman mole fraction gas ka share solution main by pressure key directly proportional hoda hai. 3. Solubility in terms of molarity. Agar solubility molarity main moles per liter puchijai formula C equal frac P KH, where C equals concentration molarity, P equals pressure of gas equals Henry's constant in mole per L atom. Units of Henry's constant. Depending on form of law, his constant form, Henry's constant unit, mass form, kb, text mole, kg minus 1, pa to minus 1, mole fraction form, p, kh, key, molarity form, c, p bar, kh, me text mole, bhat, text atium. Nanashur 5. Characteristics of Henry's law constant, tau property effect, depends on nature of gas and solvent, relation with temperature. KH increases with temperature, relation with solubility. Higher KH means lower solubility. Roman Urdu summary, agar temperature badhi to Henry constant battahe, Henry constant jitna zyada solubility utni kam. Simple numericals concept, mass-based, mass to pressure, M equal Kp. Mole fraction-based, Pu Kh Ich tas Ka. Molarity-based, C equal to P var Kh. Quick chart for memory, case formula notes. Mass solubility MKP. Mass of gas dissolved, mole fraction P equals Kh Kia. Mole fraction form, molarity, C frac K. Yes, ab clear ho gaya. Henry's law question. Q1. The solubility of a gas at 1 atom pressure is 2.0 grams per liter. What will be its solubility when the pressure is increased to 2.5 atom, assuming temperature is constant? 2. At 298 K, Henry's law constant for oxygen and water is 4.0 times 10 for 4 text atom. What is the mole fraction of oxygen in water if the partial pressure of oxygen is 0.25 at atm? Options. A, 6.25 times 10 to the C.6. C, D, 2.5 times 10 to the minus 6. D, 1.0 times 10 to 6. Pele Bilkul Theek. Pele Henry's law, of Henry's law. 1. High pressure P deviation. Jab pressure bahut zyada ho jata hai, tab gases ideal behavior nahi dikhati. Henry's law fail ho sakta hai at very high pressures. 2. Chemical reaction hoti hai, agar gas or solvent ki beach chemical reaction ho jaye is CO2 plus H2 H2CO3 to Henry's law apply nahi hota. 3. Association or dissociation of gas. Jab gas dissociate karti hai liquid main. Bond banati ya tuti hai, jaise NH3 ammonia water main dissociate karta hai. 4. Non-ideal solutions. Jab solvent or solute ki beach strong interaction hoda hai, to solution non-ideal ho jata hai or Henry's law se deviation hoda hai. 5. High temperature effect. P gases ki solubility kam ho jati hai, or predictable nahi rehti. Isliye extreme temperature par Henry's law accurately apply nahi hota. Roman Urdu summary. बहुत ज़्यादा pressure या high temperature par Henry's law ना एकता. अगर gas solvent के साथ react कर लेती है या molecules dissociate होते हैं तभी Henry का law valid नहीं रहता. ये limitations complete हो गए. Vapor pressure of liquid solutions, part 4 of solution chapter. 1. Vapor pressure basic concept. Vapor pressure equals pressure exerted by vapor particles when liquid and vapor are in dynamic equilibrium. Dynamic equilibrium, liquid molecules evaporate and vapor molecules condense at the same rate. Roman Urdu, ek closed container main liquid ke upar ban wala vapor ka pressure at vapor pressure kelata hai. Factors affecting vapor pressure, temperature increase. Vapor pressure increases, vapor pressure increases, nature of liquid, more higher vapor pressure. Addition of non-volatile solute, vapor pressure decreases. Key point. Agar hum kisi liquid main, non-volatile solute, जो could easily evaporate nahi hota. Add Karain to solution ka vapor pressure kam hota hai. Rhodes law for ideal solution. Statement. The partial vapor pressure of a component in a solution is directly proportional to its mole fraction. Formula, Pa equals Pa0 times chi A, where Pa equals partial vapor pressure of component A in solution. Pa equals vapor pressure of pure A, chi A equals mole fraction of A in solution. Similarly, for component B, Pb equals Pb times chi B, total vapor pressure of solution, total equals Pa plus Pb. Roman Urdu, solution kahar component apni mole fraction ki proportion main vapor pressure contribute karta hai. 4. Ideal and non-ideal solutions. Ideal solution. Follow Raoult's law perfectly. No heat change during mixing. Delta H equals 0. Volume change on mixing. Delta V equals 0. Examples, benzene plus toluene, N-hexane plus N-heptane. Non-ideal solution. Deviate from Raoult's law. Del H equals 0 and delta V to 0. Types of deviations. Type explanation example, positive deviation, vapor pressure more than expected, ethanol's acetone, negative deviation, vapor pressure less than expected, acetone plus chloroform. Nashar 5 azeotropes, mixture of liquids that boils at a constant temperature and cannot be separated by distillation, formed due to strong positive or negative deviation. Types, minimum boiling azeotropes, ethanol plus water, maximum boiling azeotropes, water HCl. Quick summary chart, concept key points, vapor pressure, pressure exerted by vapor in equilibrium, factors, temperature, vapor pressure, Raoult's law, Pa equals Pa0 times chi A, ideal solution, delta H equals 0, delta V equals 0, non-ideal solution, positive, negative deviation. Azeotropes, constant boiling mixtures. Next, check Raoult's law for volatile solutes. Jab solute be volatile, how do you say alcohol and water? To dono components, solute plus solvent, apna vapor pressure contribute karte hain. For component A, solvent, Pa equal Pa0, it's chi A. For component B, solute, Pb equals Pb0 times chi B. Total vapor pressure, P text total equals Pa plus Pb. Roman Urdu, dono solvent are solute volatile, hoto unka vapor pressure mole fraction key direct proportion main hoda hai. Rhodes' law is a special case of Henry's law. Henry's law, P equal Kh chi, P equals to partial pressure, Heat equals mole fraction. Rhodes' law form, Pa equals Pa0 times chi A. Comparison, jab Henry's constant key value, pure solvent key vapor pressure key barabar ho jati hai, tab Henry's law ka form, jaisa lagta hai. Conclusion, Rhodes' law ko Henry's law ka special case, mana ja sakta hai for liquid solutions. Ideal solution, definition, solution which follows Raoult's law over the entire concentration range and at all temperatures. Properties of ideal solution, no enthalpy change, delta H equals 0, no volume change, delta V text mix equals 0. Intermolecular forces between A and B are similar to AA and BB forces. Examples, benzene plus toluene, N-hexane plus N-heptane. Non-ideal solution. Definition, solutions that do not obey Raoult's law over the entire range of concentration. Types of non-ideal solution. Type, nature, reason, example. Positive deviation, vapor pressure expected, weaker AB interactions, ethanol plus acetone, negative deviation, vapor pressure expected, stronger AB interactions, acetone plus chloroform. Tag distillation, definition, a method of separating components of a liquid mixture based on differences in their boiling points. Azeotropes, definition. Azeotropes are constant boiling mixtures that cannot be separated by simple distillation. Types of azeotropes. Type example boiling behavior, minimum boiling azeotrope. Ethanol plus water, lower boiling point than individual components, maximum boiling water plus HCl, higher boiling point than individual components. Quick mind map. Raoult's law for volatile solutes, special case of Henry's law. Ideal solution, properties. Non-ideal solution, positive, negative deviation. Desiotropes, minimum and maximum boiling. Yeah, complete wa. Ready properties. Definition, properties of solution that depend only on the number of solute particles, moles, not on their nature, type. Important colligative properties. 1. Relative lowering of vapor pressure. 2. Elevation of boiling point. 3. Depression of freezing point. 4. Osmotic pressure. 1. Relative lowering of vapor pressure. Formula P squared minus PS P squared, where P0 equals vapor pressure of pure solvent, PS equals vapor pressure of solution, equals mole fraction of solute. Stin slightly relate. Roman Urdu, solution ka vapor pressure solvency kam hoda hai. Kam hon ka ratio solute ki mole fraction ki barabar hoda hai. 2. Elevation of boiling point. Definition, boiling point of solution is higher than pure solvent. Formula, delta TB KB, where delta TB, boiling point elevation, KB equals a boleoscopic constant, M equals molality of solution. Roman Urdu, solute dissolve karna se boiling point bad jata hai. Nashas 3, depression of freezing point. Definition, freezing point of solution is lower than pure solvent. Formula delta TF equals KF times M, where delta TF equals freezing point depression, KF, cryoscopic constant, M equals molality. Solute down the freezing point, kam ho jata hai. 4. Osmotic pressure. Definition, the minimum pressure required to stop the osmosis. Formula, pi equals CR, C equals molar concentration, R equals gas constant, T equals temperature in Kelvin, or pi equals frac, N, V, Roman Urdu. Osmotic pressure will pressure hai jo solvent ki diffusion ko rakta hai. Cached important points. Colligative properties. Number of solute particles, independent of nature of solute, related to dilute solutions only. Colligative properties, relative lowering of vapor pressure, elevation of boiling point, depression of freezing point, osmotic pressure. Elevation of boiling point, my delta TB, definition, when a non-volatile solute is added to a solvent, the boiling point of solution increases compared to pure solvent. Roman Urdu, jab hum solvent main non-volatile solute to uska boiling point bad jata hai. Key concept. Boiling point is the temperature at which vapor pressure equals atmospheric pressure. Jab solution mein solute hoda hai, vapor pressure kam hoda hai, islai higher temperature chahi to boil. Form delta TB equals to KB times M, where delta TB, elevation and boiling point, Ki degree C, KB equals the boleoscopic constant, boiling point elevation constant, M equals molality of solution. Molality M M equals of text, moles of solute, mass of solvent. Derivation in short, vapor pressure lowering leads to elevation in boiling point. It is directly proportional to molality, hence delta TB prop to M. Units, delta TB, Kelvin K or degree C, KB, K, kilograms per mole. Important points, concept, key points. Pure solvent boiling point lower, solution boiling point higher. Reason, vapor pressure lowers depends on number of solute particles, not nature. Example numerical, Q. 2 grams of a non-volatile solute is dissolved in 100 grams of water. The boiling point elevation is 0.52 degrees Celsius. Find molar mass of solute, given Kb equals 0.52, text K kg mole squared minus 1, 9. Solution, step 1, use formula delta TB equals Kb times M. Step 2, molality M. M equals frac text moles of solute, 1 text kg water equals 0.1. Here M equals molar mass. Step 3, substitute, 0.52 equals 0.52 times frac 2, M times 0. Step 4, solve frac 2M times 0.1 equal 191. The answer, molar mass equal 20 grams per mole. Roman Urdu summary, boiling point ziyada hota hai jab hum solution banate hain. Delta TB equals KB kex molality. Molality equals moles solute mass of solvent. Surf number of particles matter karte hain. Nature nahi. Ready for depression and freezing point. Definition: when a non-volatile solute is added to a solvent, the freezing point of the solution be lower than that of the pure solvent. Roman jab kisi solvent में non-volatile solute मिलाया जाता है, उसका freezing point कम हो जाता है. Key concept: freezing point equals temperature at which liquid and solid phases exist in equilibrium. Solute की वजह से liquid की molecules easily arranged नहीं होते, इसलिए solid form में convert होने के लिए और ज़्यादा ठंडा करना पड़ता है. Formula: delta TF KF equals delta TF equals depression in freezing point Ki degrees C, will Kf cryoscopic constant, freezing point depression constant. M equals molality of solution. Molality M price. M equals frax moles of solute, mass of solvent, units. Delta TF, Kelvin K or degree C, KF K kilogram mole. Important points, key points. Pure solvent freezing point, higher. Solution freezing point, lower. Reason: solute disrupts solid formation. Depends on number of solute particles, colligative property. Example numerical Q. 5 Gs of a solute is dissolved in 200 grams of water. The freezing point is lowered by 1.86 degrees Celsius. Find molar mass of solute. Given Kf equals 1.86, text kk mole minus 1. Solution. Step 1. Use formula delta Tf equals Kf times m. Step 2. Molality m. M equals frac 5m.2. Here m equals molar mass. Step 3. Substitute. 1.86 equals 1.86 m times 0.2. Step 4, solve frac 5m times 0.2 equals 1. M equals 25 text per mole. Answer: molar mass equals 25 gram per mole. Roman Urdu summary. Freezing point kam ho jata hai jab solute milat hain. Dap TF equals to KF's molality. Molality equals moles solute by mass of solvent. Zyada solute particles. Zyada freezing point depression. Comparison table. Property: boiling point, freezing point, change, increase, decrease. Formula: eta TB equal KB times M. Dap T equal to KF times M. Constant ebullioscopic constant Kb, cryoscopic constant Kf. Teilhard-Hoff factor mass, key factor, definition. Van't Hoff factor I is the ratio of the actual number of particles present in the solution after dissociation or association to the number of particles originally taken. Formula I equals frac text observed colligative property. Calculated colligative property, assuming no association dissociation. Yafir I equal frax normal molar mass, observed molar mass. Roman Urdu main, Van't Hoff factor will batata hai ke solute kitna tut gaya, ya jur gaya, association, solution main. Cases: situation effector I. Dissociation: X NaCl, Na plus Cl minus. Number of particles increase. Association X acetic acid dimerization. Number of particles decrease. I 1. Have no association, dissociation, particle same, I equals 1. Examples. Compound dissociation ideal NaCl, Na plus Cl minus 2, BaCl2, Ba minus plus 2Cl minus 2Cl minus 3, K2SO4, 2K minus plus SO4, 3 CH3COOH in benzene, association dimerization, IL minus 1. Observed molar mass, agar solute dissociate carta hai, observed molar mass hai. Agar solute associate carta hai, observed molar mass, zyada hodi hai. Formula: text observed molar mass, text normal molar mass. Agar Van't Hoff factor in colligative properties, modified colligative properties, elevation and boiling point, delta TB equals I times KB times M. Depression and freezing point, delta TF equals I times KFM. Osmotic pressure, pi equals I R times T. Relative lowering of vapor pressure, frac delta P P0 equals I times X text solute. Roman Urdu main yad rakhne ke easy trick. Dissociation, particles badhange, I'd 1. Association, particles kamhange, I light 1. No change, I equals 1. Example numerical. Find the Van't Hoff factor I if a 0.1 molal NaCl solution causes freezing point depression of 0.372 degrees. Given Kf equals 1.86 kg mole squares, 9 is 1 solution. 1 without dissociation, delta Tf equals Kf times m equals 1.86 times 0.1 equals 0.1862. Actual observed depression equals 0.37 degrees Celsius 3. Therefore, I equals frac 0.3.186 equals 2. Answer: I equals 2, meaning NaCl dissociates completely. Summary chart: type effect I value dissociation more particles, I 1, association fewer particles, I'd have 1. No change, same particles, I equals 1. Ready for next part? Ahum, osmotic pressure, pi, definition. When a solution is separated from pure solvent by a semi-permeable membrane, solvent molecules naturally move into the solution. The minimum pressure required to stop this natural flow of solvent into the solution is called osmotic pressure. Explanation: solvent molecules move from lower concentration pure solvent to higher concentration solution through the semi-permeable membrane. To prevent this flow, an external pressure is applied, called osmotic pressure. Osmotic pressure depends only on the number of solute particles, not on their nature. Formula: CRT, where pi equals osmotic pressure, C equals molar concentration, mole Borel. R equals gas constant 0.0821 at atmospheric mole. K minus T equals temperature in Kelvin. Alternate form, pi equals frac N VRT, where mass N equals number of moles of solute, V equals volume of solution in liters. If mass and molar mass are given, a pi equals frac Wm times frac RT/V, where a W equals mass of solute, G, M equals molar mass, G per mole. Important points. Higher the concentration of solute, higher will be the osmotic pressure. Osmotic pressure is a colligative property. It depends only on the number of solute particles. It is used to determine the molar mass of solutes, especially in case of polymers and macromolecules. Van 't Hoff factor adjustment. In case of dissociation or association of solute particles, the formula modifies as pi equals CRT, where I is the Van 't Hoff factor. Units of osmotic pressure: quantity, unit, osmotic pressure, pi, atm, Pascal, pa, mmHg, concentration C, mole L, gas constant R, 0.0821 tem, mole, -1, or 8.314 Jk, -1, -1, temperature T, Kelvin K. Now example, Q, calculate the osmotic pressure at 300 K for a solution containing 0.2 moles of glucose in 1 liter of solution. Given R equals 0.0821, text L atom mole -1, text K core -1. Solution: pi equals CRT, pi equals 0.08 to y equals 4.926. Summary property symbol depends on osmotic pressure, concentration, temperature, formula, unit, atm, pa, mmHg. Agar ab chahain to main abiski molar mass nikalta hai, wo normal theoretical molar mass si alagag hota hai. Isko kehte hain abnormal molar mass. 2. Formula for Van't Hoff factor, I equals frac text observed colligative property, text calculated colligative property. Yeah, I equals frac normal molar mass, observed molar mass. 3. Association versus dissociation key case main. Dissociation I beta 1. Example, NaCl K2SO4 in water, particles zyatahotane. Association. I less 1. Example, acetic acid in benzene, particles combine hodahane. Abnormal molar mass key exam case. Result. Solute dissociates. Observed molar mass, normal molar mass. Solute associates. Observed molar mass, normal molar mass. Quick shortcut. Molar mass, dissociation, dissociation. Zyada hotahe, important relationship. Jab question main dia ho find the degree of dissociation off to formula I equals 1 plus alpha n minus 1, where mass alpha equals degree of dissociation, n equals number of particles after dissociation. Similarly for association, I equals 1 minus alpha 1. Agar Van't Hoff factor I ka concept samaj gaya to colligative property formula sheet formula schmer. 1. Van't Hoff factor I. A. Basic formula. I equal frac observed colligative text calculated colligative property. I equals frac text normal molar mass observed molar mass. Her 2. Degree of dissociation alpha kilie jab solute dissociate karta high. I equals 1 plus alpha NS1, n equals number of particles after dissociation. Alpha equals degree of dissociation, for example. NaCl, Na plus Cl and freshness n equals 2, dash tenor 3. 3, degree of association, absolute associate kartahe. An n equals number of particles forming after association. I think we had alpha degree of association. Example, dimerization 2A, right arrow A2, n equals 1, particle after association. 4. Colligative properties key relation main, jab abnormal mass ho. Colligative property modified formula, relative lowering of vapor pressure, text RLVP equals I times text original RLVP, elevation and boiling point, delta TB equals I times KB times M. Depression and freezing point, delta TF equals I times K's M. Osmotic pressure, pi equals I times CRT. Shortcut yad rachne kilie, type of result, dissociation, I 1 month, association I, no change. Important hints, Jada particles, Jada colligative effect, small molar mass, Com particles, Com colligative effect, large molar mass. Quick example, Roman Urdu's English. Question, 0.1 mole NaCl 1 kilogram water, main dissolve kia, kidney particles benenge or Van't Hoff factor kia hoga. Solution, NaCl, Na plus Cl minus N equals 2. Dissociation 2. MATLAB 1 mole NaCl, 2 mole ions benenge. To ab main आपको pressure RLVP. Chali isko Roman Urdu means simple or clear tarik se samjhte hain. Relative lowering of vapor pressure. Definition: jab hum ek non-volatile solute, aisa solute jo evaporate nahi karta, ko ek solvent main dissolve karte hain, to solvent ka vapor pressure ho jata hai. Is vapor pressure ki kam hon ka ratio ko relative lowering of vapor pressure kehte hain. Formula: text relative lowering of vapor pressure equal frac P0 minus PS P0. P0 equals pure solvent ka vapor pressure. PS equals solution ka vapor pressure. Our RLVP directly related hodahe mole fraction of solute K minus P solute equals mole fraction of solute. Roman Urdu main easy summary. Jab solvent main solute milet hain to uska vapor pressure kam hodahe. Kam hon ka ratio minus PS blush P zero hodahe. Isko RLVP bolte hain. RLVP equals solute ka mole fraction ki barbar hodahe. Non-volatile solute का use किया जाता है RLVP समझने के लिए. यह एक colligative property है, quantity p depend करती है, nature p नहीं. Example: अगर एक solvent का pure vapor pressure 100 mm Hg है और solution का vapor pressure 98 mm Hg है, तो RLV frac 100 minus 98, 100 equal frac 2, 100, यानी 2% vapor pressure कम हुआ. Important points के लिए. RLVP सिर्फ non-volatile solute के साथ define होता है. RLVP directly proportional है solute की mole fraction से. Temperature constant होना चाहिए. use होता है. अगर आप चाहो तो इस